And of course, there are packaging constraints because the energy density issues are problematic. We need much more volume and we need to package hydrogen differently. So when we look at Airbus concepts, commercial aviation looks a bit more like this, very skinny wings because there's no fuel in them. You've got to put it in the fuselage now, and you'll see there's no windows from the wings back because that's fuel. You've got to run a longer fuselage, a little bit compromised. Can we do long distance aviation hydrogen powered? Absolutely we could. Less talked about is electric aviation, mainly because batteries are so heavy and the energy density is so poor compared to aviation fuels. But I'd like you to think a little bit more about electric aviation because I've found there's ways of thinking differently about it. So here's a guy I visited recently, Joshua Portlock, who's an engineer who's doing commercial aviation with electric aircraft in Australia. And I went to visit him because I wanted to know a little bit more about the financials. So he flies this Pipistrel, which is reverse engineered with battery packs, fully redundant systems. And then back to your context, I look at something like what Don Lipkin's holding there in his hand at GE. So he's a chief scientist at GE, and they've got these little bots they're making to put inside the engines to have a look at the blades, fatigue, cracking. Currently, the only way to get inside is with an endoscope, which is pretty bad, or tear the engine down, which is really bad because it introduces all sorts of other points of failure. So why can't we increase the safety level, increase the amount by which we, or the amount of times we inspect all of our compressor blades right down the back and just do it with tiny little bots that run down with cameras. And indeed, these ones will have little scrubbers and polishers to actually apply tiny abrasive repairs as well. Very cool. What's the efficiency dividend? And we'll measure them and we'll have real-time data and we'll have a lifelong data set of every parameter we can possibly keep. And that'll help us with maintenance, predictive maintenance and other things. I noticed a nice one in the military context where you're doing digital twins of your older Black Hawk models because you want to be able to reproduce parts on demand much more quickly. So 3D print them or outsource to suppliers, but you want an entire helicopter in digital form so you can just say, here's the design, make me one of these, because we want to keep the older variants running longer. So they're digital twins in your context. The ability to make a digital twin, though, is getting cheap. And there are all sorts of other contexts. So, for example, Ford is now creating a digital twin of one of its factories in Michigan by running one of these little spot robots around and doing the scanning, instead of a person doing the scanning. And they just update their CAD drawings with all the machinery that's been installed without permission and all the changes that have been made without logging the changes. And so they've got a digital twin of their transmission factory. And that's kind of interesting as well. But why even use a robot? You see here technology which is available today. But here's an actual quantum computer. This is a 10-qubit computer dropped into my hand about 18 months ago. So the first one I ever held. It was quite profound. Been tracking this stuff for so long. They're very real. When I talk to people in the quantum computing field, both the software side and the hardware side, they tell me they're about where computing was in 1950. So there's a lot of upside to come, but it's moving fast. Most importantly, they are working lots of real problems today. So this idea of quantum decryption, while important, is not that important from an innovation perspective. So we're going to have quantum decryption and encryption. We're going to go to a post-quantum world. That's all coming. But there's not much you can do about it. Leave that to the specialists. The fuzzier problems where this matters in the shorter term are all in the fields of simulation and optimization, which relate really closely to everything you do.